Yes, good day and welcome to my channel. Please don't forget to like and subscribe so that I can have motivation to make future videos. So now let's talk about the case of monoprotic, and let's talk about the diprotic and also the triprotic. So I am tempted to give you something of which I don't know whether I should provide it to you or not, but I just think I should. I think I should. Okay, let me just do it like this. I will do all of them. So the first one, we're going to talk about the monoprotic. So for this guy, monoprotic, this one donates one proton. Okay, so let's say for example, e.g., we have our acid which is HCl. This is a monoprotic acid. HCl, it only donates one proton and then the reaction is complete. So we have HCl and then plus H2O. I want to show you the donation, how it works. Again, you know this reaction is H3O plus, you know that by now, plus Cl minus. You see, this guy is now complete. After donating one hydrogen, our reaction has become completed over there. It only donates one proton. So we have various examples of the monoprotic acids, and of which some of them you will find out, you will do research. I just want to be quick and move on. So let's talk about the diprotic. Diprotic. The diprotic donates two protons. So, and my good people, notice that for monoprotic, always the ratio is always 1:1. The ratio of hydrochloric acid to hydronium ion is always 1:1. Please note that ratio. You will need this when you are doing pH. So I'm just giving you for reference. Ratio always 1:1 over there. That's always. So now let's talk about the diprotic. For diprotic, they commonly love H2SO4, which is the sulfuric acid, mixing it with water, giving us H3O plus and then plus HSO4 2 minus. Not 2 minus, just minus. So my good people, what you can see is that in this reaction, it might seem to be complete, but no, it's not complete. The reason why I'm saying that is because this guy, he can further donate. I get it, that one is an ampholyte. It can also donate or gain from the previous examples that we did in the previous videos. You can just check the previous videos where I was talking about ampholyte. You will see the reference. So we can still take that guy because he's an ampholyte. We can take him, mix him with water. That means in this case, he can still donate or gain, but in this case, we want him to donate so that we can have H3O plus SO or 2 minus. So having done that, you or your reaction is not complete because this thing cannot further donate. Okay, it cannot further donate. So the reaction is not complete. It completes diprotic reaction completes in 2 steps. Okay, so but the problem is we have 2 reactions, but we only need 1 reaction. So what I advise students is that you do this in a very educated way. You look in left and right sides. You ask yourself, do I have sulfuric acid in both sides? I mean, in the left and in the right. You will find out that no, you only have it on the left. So which means you have it on the left only, you write it down. It doesn't have competition. No competition. So from there, you're going to say, okay, what about this thing? Or what about the water there? What about the water? What about the water in the 2 reactions? What you will see is that in reaction 1, I have water. In reaction 2, I have water. So what we do, if they are in the same side, they're in the same side, which means they support each other. That means they're just going to add, and then we get 2H2O, because this is 1 and 1 is going to form 2H2O over there when we add them. And then now, that means you're going to the second guy, this guy, HSO4 minus. You ask yourself, do I have HSO4 minus in the left hand side and in the right hand side? Yes, I have him over there, and I also have him over there, which means that guy is actually going to cancel. They are opposing each other. You know that if I take this thing to the other side, it's going to become a negative, and then they will eventually cancel out. So this one cancel and that one will cancel each other. All right, it's fine. I think we're sorted. That means we're going to the product side now. We're going to now the product. And then when we go to the product side, if you check, I have H3O plus, H3O plus on the same side. That's 2H3O plus. And then plus, this guy doesn't have competition, so he already won. 4, 2 minus. So my good people, having done that, you will realize that the complete reaction is this one. And then in that complete reaction, the ratio of what? Of sulfuric acid to hydronium ion is 1:2, always. Just like that. You solve it like that over there. So some of you might find other diprotic reactions and then just attempt to do it that way. Just attempt to do it that way. And then lastly, for triprotic, we have things like, okay, let me just, for triprotic, you basically apply the same thing, okay, because we have something like H3PO4 over there. You apply the same thing until you have PO4 3 minus, until you have this thing. That's where your reaction will be complete. I want to talk about the base. I want to talk about the triprotic. It's not that much of a problem. Let me come to the base now. For monoprotic, let me just write it over here. You know that we have NaOH, which is a base. A base actually breaks down. When it breaks down, you will have Na plus OH minus. That's what a base does. So some of you might be wondering, why am I actually changing? I'm not changing. On the previous lessons, I was using ammonia because ammonium is a special case. Ammonium is very special, different from others. That one ionizes instead of breaking down, instead of dissociating. Okay, so now for that's one example for a monoprotic base. But let's talk about a diprotic base, something like CaOH2. And I'm saying that a base actually breaks down. And then when it breaks down, this subscript will come back to a calcium there, and then you have Ca2 plus, okay? And then now this guy, OH, I'm going to have plus OH minus over there. So which means now you have to work on balancing the reaction. You have to maintain, to check whether the reaction is balanced. And then you maintain that balance. If you check this one, it says 2 OH. I have 2 OH this side, but here I have only 1 OH, which means I can put a 2 over there so that I can have 2 OH and 2 OH both sides over there. And then I have 1 calcium, 1 calcium. That means the rest is balanced. You just do it like that for the bases over there. Thank you for watching.